with our OSI model assignment for 2.1. We will go over what we did in that, how we were able to solve any challenges, highlight any flags that were hard, and explain how to solve them, and my overall impression of the room. I did start a little digital notebook to also help me go over this. So first we went over what is the OSI model. OSI stands for Open Systems Interconnection, and it provides framework dictating how all network devices send, receive, and interpret data in 7 layers. Encapsulation is the key term for whenever pieces of information get added to the data. As we see in the actual room, it covers all of that in a higher quality. And you can see that I answered those questions in my notes as well. So we start with layer 1, which is the physical layer. It's the layer that references the physical components of the hardware used in networking, such as these Ethernet cables right here. It uses a numbering system of zeros and ones. The data link focuses on physical addressing of the transmission and receives a packet from the network layer below, including the IP address, and adds in physical MAC addresses from the receiving endpoint. This is done by a network interface card, also known as a NIC. Then we have network, which is how we get from computer A to computer B using the IP addresses. And these will take the most optimal route using the open shortest path first, also known as OSPF. RIP is for the routing information protocol, and I already said that. Okay. I'm not going to do much editing to this video just for authenticity. In the transport layer, we got into a bit heavier of a note point. Transport is where the data is sent between devices and follows one of 2 different protocols those are decided upon several different factors. You go over the advantages and disadvantages of transmission control protocol, also known as TCP, and those are sent through several packets to get a complete final. And then we also go over user datagram protocol, UDP, which is much faster, but it leaves the application layer and doesn't reserve a continuous connection, which can cause it to break up between the packets and result in a messed up final. Layer 5, oh my goodness, you decided to glitch. Layer 5 is the session, which is when a connection is established, it is created, and it'll contain checkpoints if data is lost, saving bandwidth. Then we have layer 6 presentation, which is where standardization begins to take place and acts between a translator between the different layers. And then finally, layer 7 application. Oh, that's it, okay. And that is the layer which most people have familiarity with, and this layer decides which protocols and rules are in place using graphical user interface, GUI, or domain name system, DNS, which is how website addresses are translated into IP addresses. So in this little practical application, it gives us a little challenge. Basically, it's making sure we know the correct ways that the layers are in order. So it goes physical first, then data link, I went too far, network, then we can look back over here and know that it's transport, session, presentation, you keep scrolling down, and then finally application. Now it says that they completed it in a record time of 19 seconds, but because of the keyboard controls, I highly doubt that. All right, and then from there we will move on to packets and frames in the next video.